have in one spot. The first one we actually just reviewed for our warm-up. What was sine of 2a equal to? Sine of a plus a, but if we condense it down, what was the property? Is that all right? That's right. Yeah. You can write 2 cosine a sine a if you want, but it's usually written like that for some reason. Then we had cosine of 2a that we proved yesterday. And when you use the composite argument property on that and simplify, you end up getting cosine squared a minus sine squared a. Because remember, if we were to split that up into a plus a and use the composite argument property, you'd get cosine a minus sine a, and then you could square them. And then there's 2 other versions that you can write this as, because since we have cosine squares and sine squares, we could use the Pythagorean property and replace to, make it all in terms of one function. So if you replace the sine squared and simplify, you would end up getting this expression. And if you were to replace the cosine, you'd end up getting this expression. So these are just manipulations of this first one, where we use the Pythagorean properties to rewrite. Now this is all on your property sheet as well, but I also like to include it in your notes since most of the examples we're going to be doing are using these specific ones. And then the tangent one, I didn't make you prove. There's only one tangent one for the double argument property. And that's 2 tangent a all divided by 1 minus tangent squared a. Little note that I want you to make here, and we kind of touched on this yesterday, but all that matters really for these double argument properties to apply is that one argument is twice the other. So if one argument is 6x and the other argument is 3x, would these properties apply? Yeah, because one is double the other. Or if one was 10x and the other one was 5x, then they would apply. Now, let's look at the sine. You don't have to write this one down, but let's say you had sine 2 or 10x, and we wanted to use the double argument property. This is double of what argument?
5x.
5x. So we would rewrite this as sine of 2 times 5x like that. Isn't that the same argument, essentially? Just 2 different ways to write it. This way of writing it, though, allows us to use this property, and then the 5x would become my a. You see that connection there?
So just be 2 sine 5x and then cosine 5x?
Correct, yeah. If we were going to convert this using a double argument property for sine. So the little note...
Is that going to be like a, I don't know how you do the tiers or whatever on your test, if you had tiers, that would be like a basic knowledge question?
To change, that would be the basic use of the property. Yep. I don't really do tiered questions precisely, but when I test you over one standard, I do make sure there's a basic, a medium, and then an application. So I tier them kind of without telling you.
Yeah, that's paper towel.
Huh? Yeah, I couldn't stand that question.
Yeah.
What question?
Paper towel.
That was like the only one that I got like
Make sure you're writing this little note down as you're complaining about my question. Okay. For properties to apply, all that matters is that one argument is twice the other. For properties to apply, all that matters is that one argument is twice the other. Okay. Then we're going to do some examples here to properties just to use them. Problems. So, for example 1, they're giving you a value of cosine x. Anywhere in here, does it give you what x is? Does it give you the angle? No. I mean, eventually it tells you to find the angle, but in this case it doesn't give it to you. But they do give us the value, and in this value they tell us to find the exact value of cosine 2x. Well, hopefully you recognize that is a double argument. And so, if I need to find the exact value, and all they give me is a cosine value, they don't give me a sine value, then which one of these 3 options should I choose? Probably the second one, because it only involves cosine. Since I'm only given a cosine value, then I can only choose the one that has just cosine. So I'm going to write down that second option. That's why it's nice to have 3 options, because it allows you to not have to have both sine and cosine values. The exact value means we need to be able to plug it in without finding what x is. So that's what we're going to do first. Cosine of A, well, we could write this as that. Like, that's just 2 different ways to show cosine squared. This way it might be a little bit easier to recognize, okay, now if I'm trying to find the exact value, that means I'm probably plugging something in. What can I plug in for cosine of A? 0.3, because that's what cosine of A is, or that's what they gave me. So I'm going to go ahead and plug in 0.3. And then I don't think I'm going to have to round it all, because probably 0.3 squared gives me a nice decimal. 0.09. Yep. So if we have 0.09,
Why 09?
Pretty sure it's 0.9. Would it be?
3 times 3 is 9.
right? But 3.3 is 3 over 100, or 3 over 10, isn't it? So 3 over 10 times 3 over 10 would be 9 over
So
100.
whenever
So
you're
0.09.
squaring decimals, you have to like make it into a fraction and then.
We don't
split
have to,
those.
but that's what's
It
happening.
is 0.09. Look at
Yeah.
that.
But did you catch why?
Yeah.
Yeah, I caught it.
Okay, because this means 3 tenths, and 3 tenths times 3 tenths is 9 hundredths, which is 0.09. Yep.
Decimals and.
So we have 2 times 0.09
Oops.
minus 1. 2 times 0.09 would be 0.18, right?
18%.
And then 0.18 minus 1 would give me what?
Negative 0.18? Or negative 0.10?
Something
Point.
negative.
Negative 0.82.
Hooray.
Okay, now if that's my answer, and that is found without having to find x, they want me to check my answer numerically by actually finding the value of x, doubling it, and then finding the cosine of the resulting argument. So this is like what you would have to do if we didn't have this property. Okay? So how do I find the value of x using this expression here?
Inverse cosine.
Inverse cosine. So I'm going to take the inverse cosine of both sides. Inverse cosine of 0.3.
What happened to the 2?
Make sure you're in radian mode.
Wait. Oh, yep.
I'm not quite sure where the 2
For
went.
it.
Everyone else went out. Where'd the 2 go?
What do you mean the 2 go? There isn't one here. I'm finding the x here, and then I'm going to plug x back into this one once I find x. 1.266. Okay, I'm going to go ahead and store that as an x here, just so that I get the full decimal so I don't have to round. Here I'm just going to show 3 decimal places, but on my calculator I'm going to use the whole decimal. Then it says, okay, once you find x, then you're going to double it to show that you're plugging it in here, so maybe we even show that. So you multiply by 2. And then you're going to find the cosine of that value there.
Oh, so this is just the check part?
This is just the check part, yeah. And we should show...
Are you going to want us to check on the test too? Is that going to be something special?
Probably not.
Good.
you get negative
What's this for?
0.82?
Like what?
Wait a minute.
What?
Oh, you stored that.
I stored the first decimal as x, so then I just doubling it gives me that, and then if you were to take the cosine of that, you should get negative 0.82.
Oh. So essentially you were taking the cosine of 2.52.
Yeah. This store button here, Kelly. So once you have a decimal, you can hit the store button after that decimal, and then store it as a variable, and then whenever you punch in that variable, it treats it like that decimal. This is just the check to show that if we didn't have the property, we could go through that whole long process and get the same value, but using the property does allow us to cut out some work. Yep.
For some reason I got an error when I tried to put in cosine of 2x.
Are you integrating?
What mode are you in?
Did you store
Yeah.
the x? Are you in the right mode?
Oh shit.
Really?
Percent.
That's right.
That is percent.
Your calculator comes with
I
it.
got it right
Yeah.
now.
You might not have stored it correctly. I can look at it here in a minute. Okay, for example 2. So again, that's just using, if they give you a cosine value, they're just asking you to use the property and apply the property. Example 2 is very similar. Write an equation expressing cosine 10x in terms of sine 5x. Okay, first thing that you need to identify is one argument double the other? Okay, that means you can use a double argument property. If it wants cosine 10x in terms of just sine, then
Down at the bottom there, third one.
that third one looks like it's going to be my option. Okay, so I'm going to write that property down. Cosine 2a equals 1 minus 2 sine squared a. And then I'm going to rewrite my cosine expression here. So cosine 10x, in order to make it look like this, I would have to write it as 2 times 5x, right? It's the same thing as cosine 10x. But in order to make it look like that property, I have to rewrite the argument. And then when we use the property, my a is 5x. So I would plug in 5x for a. And is your equation
Yes.
in terms of just sine 5x?
Yes.
Yeah. Even though sine is squared, sine just has the argument 5x, you're done.
And that's right.
That's it. Yep.
Would that be another question?
Yeah.
Oh.
It's just using the properties.
Is that the harder one?
No.
Wait, are we using our property sheet on the
A
test or
multi-step.
not?
We're gonna
Yeah.
use a multi-step.
We are?
Yep. So you could make a therefore statement.
Like smack dab in the middle.
Use that to find the.
Well, it asked for an equation in terms of sine 5x, so you could write it as an equation that looks like that.
Use the
To show cosine 10x in terms of just sine 5x. The other thing you might want to add to this is that the double argument property you want to use must only involve sine. Now, what if this question said in terms of sine 5x and cosine 5x? Then what double argument property would you pick?
The first one.
The first one, because it involves cosine and sine. So you just have to pay attention to what they're looking for, and then look at your 3 options and pick the one that makes most sense. Alright, hold it. Okay, this is going to make you play with the properties again. We're supposed to write the equation in example 2 directly from the composite argument property for cosine. So this is using the composite argument property that we've dealt with before. So if I wanted to write cosine 10x in terms of just 5x, let's say, we're going to split up that argument. But if I'm trying to make it a composite argument now, it would have to be what plus what?
5x plus 5x.
5x plus 5x. So we would write cosine 5x plus 5x. This is just applying the properties we've been dealing with. Alright, and then let's go with...
And then you just put it into
to get to the same result that we did on the previous page. Alright, Mariah, can you tell me what the composite argument property is for cosine of A plus B? You can just tell me like what it would be for this one. Okay, so I could write this then, since they're both the same argument, I could write that first one as cosine squared 5x, right? The second one as sine squared 5x. And then if I just want it in terms of sine, what would I have to replace?
Change the cosine squared 5x into sine squared.
Yep, change the cosine squared, but using what properties? Pythagorean properties, because that's what we would have to use there to change that to a sine squared. Yep.
1 minus 2 sine squared 5x.
Yep.
That's 2 squared.
Okay. And then since we have two of the same term here, we can combine them and make that 1 minus 2 sine squared 5x. Isn't that what we had on the other side? Yep. So this is, again, making the connection between, remember how yesterday I talked about how all of your properties past the composite argument properties are basically manipulations of the composite argument properties. So everything's built from that. So if you don't remember to use a double argument property, you can still get to the same results by going back to the composite argument properties and using those. And if you did this in a problem, instead of using this, you would still get the point for it. Because you would still get to the same result. Alright, half argument properties. Let's start with cosine squared x equals 1/2 plus 1/2 cosine 2x. The half argument properties are derived from the square of cosine and the square of sine properties. Those are ones that we talked about yesterday.
So cosine 2x.
Yeah. Yesterday we looked at our sheet and we said, okay, the ones on our sheet actually pulled out that 1/2, so we're going to do that here. And then the half argument means that one has to be half the other. Well, if we look at the two sides, is 1/2 the other argument?
Yep.
Yeah. I'm going to rewrite these arguments now instead of in terms of x and 2x. Rewrite it how you would normally see your property.
How's it half though? That's 2x,
X is half. 1x is half of 2x.
right?
Just one has to be half the other. So this is 1/2 of this other argument. This is actually more what the property would look like. They wouldn't write it as 2x and x. They'd write it in terms of like 1/2 the other.
This cross, where's
Yep.
the 1 plus go? So you had half times 1 plus cosine squared. Why isn't it like 1/2 plus cosine squared?
Pull it out.
1/2 plus cosine squared.
Well, because you said cosine squared of x equals 1/2 times 1 plus cosine 2x, right?
Yeah.
Well, what happened to the 1 in 1 plus cosine 2x?
Are you talking from this step to this step?
No, I'm talking
going
about why
across.
cosine squared equals that.
This?
Yeah.
Nothing disappeared. All I did was pull out a 1/2 out of each term.
Where'd the 1 come?
Yeah.
Because if we were to redistribute, you'd have to have a 1 there
To get the 1/2.
to get the 1/2 on top. If I redistributed this 1/2, wouldn't I get what I started with?
Yeah.
Yeah. So all I did was pull out the 1. And the only reason I do that is because on your property sheet, that's how it's written. Is with the 1/2 outside the parentheses. Okay. And then the last thing that they do here in your property sheet is they get the cosine by itself by taking the square root of both sides. And whenever you take the square root of both sides, you end up getting a plus or minus there. And so on your property sheet, this is what the half argument property looks like. But it's derived from this one, which we proved on the very front of the objective. And again, on the test, you don't have to prove any of these properties, but in your notes, we prove them so that you can use them. So I'm doing the proofs with you so that all you have to do is be able to use the properties from your sheet. Alright, the way you choose whether your value will be positive or negative is to figure out what quadrant your 1/2 A or that half argument terminates in. This will determine your sign. And we're going to do examples with that so it makes it a little bit easier to figure that out. Alright, so the first half property, so you have double argument properties and then you have half argument properties. Depending on the problem, it might ask you to use one over the other, or it might make more sense to use one over the other. And again, these are all derived from those cosine squared and sine squared properties, but I'm not making you do all the proofs. Cosine 1/2 A is the one we just came up with up here. So that's going to be plus or minus 1/2 of 1 plus cosine A. And then tangent of 1/2 A actually has 3 different ways that you can write it. I'm not making you prove this one either. But the half argument property for tangent, that's the first way that you might see it. Yeah, because I'm giving it to you at this point. Making you prove every single little property would be very tedious. So I just make you prove the main one, and then we kind of write them all down. So these are the 3 different ways that this property can be written. Now, if we wanted to, if I gave you an A value, we would be able to punch out each one of these fractions, and they all give us the same value.
Are they still square root?
No, just the first one's the square root. And again, like with tangent, if you're supposed to find the value, the exact value of tangent 1/2 A, and they just give you cosine, then this is probably the option that you have to choose, because this one just has cosine in it. If they give you sine and cosine, then you could choose one of these other ones that don't have a radical over it. Alright, we're going to use properties. For example 4 here, I think we need to draw a picture. Well, we will in a minute. Alright, they give us some exact values. This is like example 1 that we did where we were given cosine of x equals 0.3. I don't want you to find A here. I want you to use the value they give you and then use the properties to find the exact value. When you see that phrase, exact value, that usually means there's properties involved instead of actually punching out like the inverse cosine to find what A is. Alright, so if cosine of A equals 15/17, and A is in the open interval from 270 to 360, first of all, what quadrant is that?
Fourth.
Why would that make, or why would we need to know that?
Because only cosine is positive.
Because
Cosine.
Only
Cosine's are positive.
that's the only place that cosine is positive other than the first quadrant, right?
Yeah.
So they have to narrow it down to one quadrant so I know where to draw my triangle. Because probably I'm going to have to find something in there with a triangle. Then we're supposed to find cosine of 1/2 A and the exact value of cosine 2A, and then verify numerically. So we'll do the verifying at the very end. First thing we're going to actually do is draw my picture here. So cosine, in terms of a reference triangle or just any triangle, cosine is adjacent over hypotenuse, right? But in terms of the quadrant, cosine is always related to your u over r, right? Sine, if we were given sine of A, sine would be v over r. Okay. So that makes a difference here because when we draw my reference triangle, first of all, it has to be in the 4th quadrant because of this open interval situation. That's the 4th quadrant. And then the 15/17 here, this is my u and my R, so that gives me the sides to label, 15 and 17.
Do we have to do the Pythagorean thing?
We might, I don't know yet. We might need to. But at least get it drawn.
This is like with the axes being U and V, right?
Hmm?
The x-axis is U and the
Mhm.
y is V.
Yeah, and we could even label it like that. Notice that this expression they give me, the argument is angle A. So this angle all the way to where that reference triangle is, that's angle A. But we need to find the exact value of cosine 1/2 A. So where would the angle be if you're trying to find 1/2 of A?
Half of that.
Half of that. In the second quadrant. So we're going to draw a little dashed line here to show that that angle is 1/2 of A. So we don't know what A is, but whatever A is, half of that would be just the opposite quadrant. So if we had something in the third quadrant instead, then half of A would be in what quadrant? If we had the reference triangle here, then it would be in the first quadrant. If we had the reference triangle here,
Fourth
then it would be in the fourth. So it's just the opposite
quadrant.
quadrant. Yep. Alright, let's go with the first one. Cosine of 1/2 A. Okay? Now this is where you look at your property sheet, so if you don't already have it out, I want you to get it out. So you don't have to keep flipping back and forth. Okay, and looking at your properties, since it gives me the value of cosine, does cosine 1/2 A have a half argument property where it's just in terms of cosine?
Yes.
1/2 is the
Square
only
root of
one
1
that
plus
has it.
It's
cosine.
the only one that it has. So it's equal to plus or minus the square root of what?
1/2
1 half of 1
times
plus
1
cosine.
plus cosine.
1 plus cosine?
A.
In this case, yeah, we're going to write A here, but you can use whatever variable you want. Alright, we're supposed to find the exact value. That usually means no decimals, at least no rounding.
So when you're doing things like find the sine of the triangle, like say you were doing so like an exact value of tangent
Yeah.
of theta would be that blank angle over there, or 15, where you're not punching anything out.
Yeah.
Because if you punch it out, it doesn't come in dash anymore.
Well, if you punch it out, it usually means you're rounding.
Oh, so that's why it says exact.
So exact, I mean, this would be an example of something I would put on the non-calculator portion. Because I'm not asking you to find angle A here. I'm asking you to use the value they give you to draw a triangle and to plug stuff in. So this would be a non-calculator type problem. Yep.
Just if you find half of or cosine 1/2 A, can't you just like multiply that by like 4 to get 2A? To get cosine 2A? Wouldn't that work?
Yeah. Well,
Instead of having to do all that property stuff?
maybe.
Times 2 would be 1A, and then times
No, yeah, I know what you're saying.
rather than having to do all that property stuff.
But we don't know what A is.
Well, I mean, just
Once we find the
once you
value
figure
here.
out cosine half.
It might work out that way. It might work out that way. But hold that thought. Alright. One thing I forgot to add here, your first step.
Let me edge my seat.
Always sketch your angle A, because especially if they give you like a quadrant, it's good to draw a picture at least. So always sketch angle A and 1/2 A and your reference triangle. That's always a good place to at least start. Okay, so back to this property. If we need to find the exact value of cosine 1/2 A, we look at our property sheet and we can see that, okay, this is my only option. Thankfully, we have the value of cosine of A. That means I can go ahead and plug in what for cosine A?
15/17.
15/17, because that's what cosine of A is equal to. So wherever I see cosine of A, I can now plug in this fraction that they've given me as its value. Then it's just some probably simplification here.
32/17 is.
Now, you could choose to distribute the 1/2 through, or maybe we choose to get common denominators inside first. If we got common denominators, the 1 would become 17/17. And then 17 plus 15 gives me what? 32.
32. Then can you multiply 17 by 2 to get the half?
Which is 34, so it's 32/34.
So it's 32/34, which reduced is 2.
Something.
32/34. 16/17.
16/17. Good. So we could get it down to plus or minus square root of 16/17, which, I mean,
You could rationalize.
we could rationalize this, because square root of 16 is what?
4.
4.
So 4 square root of 17/17.
Now, we do have to, now I'm just rationalizing at this point to get that 4 square root of 17/17. But we do have to pick whether this is positive or negative. And this is where you have to pay attention to where the angle 1/2 A terminates. It's going to be negative. Why is it negative, Donnie?
Because all students take calc, that's the sine quadrant.
Good. If 1/2 A terminates in the second quadrant, that's where cosine is negative. And so you're looking at cosine 1/2 A. You're going to have to pick the negative version. And it's negative because 1/2 A terminates in the second quadrant, where cosine is negative. Okay? I will have students that will do this and they forget to choose whether it's positive or negative. You can't have two answers here. You only have a positive answer or a negative answer. And you always figure that out by what? By your picture. So that's why we always start with a picture to show where 1/2 A will terminate.
Won't it always be negative?
What?
Well,
Yeah,
I mean,
well,
it'll always be negative unless you're using tangent, won't it?
So,
Depends on where the reference triangle is.
Well, I'm saying like if you're in the sine quadrant, then
Yeah.
half is going to be in the cosine, so your answer is going to be negative. And the same for cosine, but the only time that it's going to be positive is if you're in tangent, and then it'll be in the first quadrant and everything's positive.
Yeah.
So your answer's always going to be negative unless you're using tangent.
Well,
Unless.
because you can't have like the negative angles. You don't have the quadrant.
Unless somehow
Right.
unless somehow you're using like 90 degrees, which
No, you wouldn't ever use 90 degrees, but there will be times where your 1/2 A will end up in the first quadrant or the fourth quadrant, and so.
That's true.
wait,
The
how
negative angles
can
is-
half of your reference angle end up in the same quadrant?
Not half of your reference angle.
Or half of
Your angle.
your angle, yeah.
when tangent.
What I'm trying to say is like your answer, half of
Oh,
your angle is.
I might have
always going
explained
to be-
something not clearly before. If we had that as my reference triangle, so this angle right here is angle A, half of that would actually be where?
first question.
In the first quadrant.
Oh, got it.
So it's not automatically, I think I maybe misspoke before. It's not automatically the opposite quadrant. You do have to look at how big angle A is and then just figure out where half of that would be.
Okay.
So half angle A would actually be in the first quadrant.
Yeah, I guess the way that he said it before, it's always going to be
Yeah.
negative.
Yeah. Yeah.
So
But
The
it's not
opposite
always
quadrant is
negative.
always going to be negative unless you're in the third quadrant.
Right.
So if you're in the fourth quadrant, that's the one you're going to have negative.
Yes.
Okay.
Yes. Okay. For B, we have to find cosine of 2A. Now, we're going to use the property here, and we can't just multiply this by 4. And this is why. Because the half angle property is derived from the cosine squared and sine squared properties. The double argument property is always derived from the composite argument properties. So you do just have to use the straight properties. But with cosine...
If half of A, it's the same variables, essentially.
let's try this numerically. Let's just choose an angle measure. Doesn't really matter what. 84? Well, let's go radians. So let's 2 pi. Okay. So if we take, let's say A is 2 pi. Okay. So cosine of 1/2 of that would be cosine of pi, right?
Right.
Okay, so if we plug that in, we get that value.
Yep.
Okay. And if A
I
is
guess we get that value.
right. Oh, you can't even see it. -1.
Yeah.
All right.
Makes sense.
And then if we had, wait, what was my A? 2 pi.
Yep.
So double of that would be 4 pi, right? So cosine of 4 pi.
Wait, where'd you get pi from again?
We are just testing out Donnie's theory that if we have the value here, we can just multiply it by 4
Barrier of that.
to get the value for cosine of 2a.
Probably.
But I'm showing numerically that can't happen. Because if your A is 2 pi, half of that is pi, double of that is 4 pi, but when you actually plug it out, it gets two totally different values. It wouldn't get the same. Like one's not multiplied by 4 to get the
Right,
other.
so if you were to multiply negative, it would be -4.
Right.
Okay.
Does that make sense?
Yeah.
Okay.
Kind of disappointing.
I know. All right, looking at your double argument properties, and I'm going to ask, let's say Chelsea and Taylor, if you guys can find maybe the double argument property if there's one that just involves cosine.
That really because it's the same thing.
And then one of you give it to me.
2 cosine squared x minus 1.
Good. All right. When you have these properties, especially if they just give me the cosine value at the beginning, try to use the property that just has cosine. If you try to use cosine and sine, then you have to find the third side here, and then it's just a little bit more work. A lot more work. All right. So for this example, if we're trying to find the exact value, that means I'm just using the value they give me and plugging in where it goes. So cosine of A is, what was cosine of A equal to?
15/17 squared.
15/17. So I'm going to replace cosine of A with 15/17. Square it. And then the rest of it's just simplification of the numbers that are there. So 15 squared is 225, I believe.
Yep.
Yep.
And then 17 squared is 289.
Yep.
And then 2 times 225 would be 450. The 1, in order to subtract, would actually be 289/289. So 450 minus 289 would be
Some
1 something.
1.
161.
Yeah.
161 over 289 when you actually subtract. This is the answer that I would expect to see. If you can reduce, do it, but normally you can't reduce at this point. I don't want you to punch it out to a decimal. Maybe something we need to add to our notes here, just for later. Is when you're trying to find the exact value, they usually give you one you can use. So remember, cosine of A equals 15/17. That's where we could actually replace cosine of A with a number, because they give me that equation at the top. Okay. All right, I'm not going to make you double check these. If we were to find angle A and then find half of that angle and find double of that angle and punch out the values, they would match these two if we punch these out. And the reason I'm not making you do it on your notes here is because on a test, this would be on a non-calculator portion, so you can't check your work.
Are these going to be, is this going to be 2 separate problems, or is this going to be a whole problem on the test?
This would be like a whole problem, but probably testing over 2 standards.
What do you mean?
Did you catch what I said?
Yeah, I got it.
All right, we are going to practice some of this stuff, so go ahead and grab a whiteboard. Alright,
How come it's not done?
Why'd you give them back to me? I give them to them again.
alright.
I want brownies. That was Also, can we have the big bag?
What's his name? Wasn't Baggers? Was like Baggers or something.
Okay, since the example that we just did is the more common example that you'll have to deal with the properties, I want you to do number 22. I'll zoom in. It's very similar to the one we just did, except it's asking you to find cosine of 2a and sine of 1/2 a, and it gives you that value, that cosine of a equals 3/5.
Does anyone?
Would you like to attempt the basket?
What? Wow, Chase.
So, is it wrong for me
Number
to log
22 is the one you're working on right now. Draw a picture.
They don't work.
You'll do it.
Whoa! Just got threatened by Shane.
Yeah.
I didn't threaten. I was
You
kidding.
threatened me? No,
No, I didn't threaten.
Area.
Miss Cross,
Which
Black.
one? Oh.
Is it
Sorry.
ours?
I have a green one, but that should be marked yet. Don't we have to write property?
Yep.
Yay.
Negative
We're good?
7. Number 24 now.
Oh.
Yep.
Just kidding. Do number
Something.
Aw, Miss Kelly.
Supposed to be negative.
Okay.
I know.
Positive sign
do
immediately.
number
Got it.
25.
I did.
there for
Yeah.